Welcome to the dynamic learning hub of ExcelR at Andheri East. A prime spot conveniently located at just a 5-minute walk from LIC Andheri Metro. In our journey of over a decade, we have proudly trained over 2 lakh students. We have also been recognized by Deloitte, Silicon India, and other accreditation bodies. Experience learning like never before in our spacious and comfortable classrooms. With high-definition projectors and state-of-the-art acoustics in place, we ensure effective learning even to the farthest point in the room. The hybrid mode is a game changer as you can enjoy the benefits of a live classroom from the comfort of your home. Even if you happen to miss any classroom session, you can still attend the same session with the same trainer at the same time at your convenience, maintaining consistency in your learning progress. Wanna get started? Join us for a demo or career chat over a cup of coffee at our Andheri branch. ExcelR. We don't just train, we build careers.
Yes, so the collaboration with ExcelR was an excellent one. We conducted a Power BI workshop with Advanced Excel over a span of 3 days. The workshop was almost 12 hours long in total. Mr. Karthik, who was an amazing trainer, helped the students understand the concepts deeply. I am sure that the students will be able to apply these concepts in their careers as well as their daily lives.
The trainer, Mr. Karthik, was an excellent person where he explained in very detailed manner on how to give great insights using very complex data sets.
So it was a machine learning workshop. We learned a lot from the course and it was a great experience attending the workshop.
The trainer was very helpful. He had a hands-on approach with his teaching and it was fabulous.
This was a great experience for me. So I would absolutely love it if ExcelR and its team would come again to our campus and conduct more events like this.
It was a great course and it started from basics and took me to a great extent.
The experience of the workshop was really nice. The feedback from all the students was positive. They understood the concept. The workshop was also practical based with some questions. The experience with ExcelR was very smooth. They helped us in conducting the workshop smoothly right from the booking of the vendor and deciding the course till the distribution of certificates. In overall, this workshop was a success during our Technical Fest Atmos, and I thank ExcelR for being a part of it.
was very much interested in learning digital marketing course for a very long period of time, but I don't get a proper platform. So later from our college, I get to know about ExcelR and I enrolled in ExcelR course. It was really good experience. Our course has been taken by Mayur sir, and he was very good teacher. He not only focusing on theory part, he is doing how real digital marketing works, and it was in total very good experience. I get so much of knowledge. Here they not only focusing on study, they are also conducting different exam to test our knowledge, and as we are giving the exam, so to appreciate our work, they give certificates for the toppers, and along with the certificate they give hampers. Thank you, ExcelR.
Recently, I was searching for digital marketing courses online in Google, and I came across ExcelR, and I attended a digital marketing course which was for 15 days. My mentor Mayur helped me for attending these classes. So he is a very informative and helpful guy. In the course end, there is a exam which I topped, so I came to the ExcelR office in Bengaluru. This digital marketing course has helped my career and my skills to develop, and the certificate has helped my company to join. Thank you, ExcelR.
Good evening, all. We'll start the session for the day. It's a good evening. Is I'm audible to everyone? Adil Yusuf sir, is I'm audible?
Yes, ma'am. Yes, ma'am. You are audible.
Yeah.
Good
we
evening,
can
ma'am.
start the session, sir. Good evening.
Sure, sure, sure. Okay. Yeah, good evening, everyone. Hope you are fine and doing great. May I know what we discussed yesterday? In quick 1 or 2 minutes. Yes. Then we will proceed further. Yes. May I know? Yes. Great. Okay, we discussed something about the OOPS concepts. Like data abstraction, encapsulation, inheritance, etc., etc. Right? Some basics. Then we discussed about arrays. What are arrays, one-dimensional arrays, two-dimensional arrays, etc., etc. And what today we'll be going to do, we'll be going to perform some operations on the arrays. Right? Yeah, let us discuss. Hope my screen is visible to you. Okay, give a quick confirmation. Great, it is visible. Fine. Now what we'll discuss today, it is actually the operations on an array. What are the various operations that we perform on arrays? Right? See, the very basic operation, or I can say the first operation that we are going to discuss today is, it is insertion in an array. And you know, insertion is simply adding a new element to an array. Right? So whenever we are having an array and you are going to insert a new element into that array, so we call that operation insertion operation. Right? And this addition can be at any location. Means we want to add the element at any specified location, right? For example, if this is an array, and we have discussed what array is, it is actually a homogeneous collection of data elements, items, right? Homogeneous means similar kind of the same data type. Now let us discuss this algorithm. How do we insert an element into an array at a specified location? This is actually a pseudocode, or I can say an algorithm. Fine. These are some of the steps that we have to learn in order to insert a new element into this array. Yeah, be careful. See, once you will be knowing, or I can say once you will go through this algorithm, you have a clear understanding of this algorithm, only then you can write a good program. In order to write a program, the main thing is you should be able to devise an algorithm, how the things are actually going, right? So for that purpose, I have written an algorithm over here, and we'll be going to discuss this algorithm, right? See, initially start, and we have discussed an algorithm about the definition of the algorithm, that is simply step-by-step process to solve a particular problem. So this is the step-by-step process that we are going to follow in order to add a new element into an array, right? So the very basic step is what? It is start. So we are starting from this. Then yesterday we also see it, how do we declare an array, that we discussed yesterday. Today also we'll see in a program when we write the program for it. So we'll be declaring an array and the variables. What are the different variables that we are going to use in order to insert a new element into an array? So this is the basic thing. First of all, we have to declare an array, that we discussed yesterday, that we wrote a program for that as well. We'll be again seeing it. Then we'll be declaring the variables, right? Like the size of the array, the capacity, at which position we are going to insert the element, and what is the new element that we are going to insert. So these are some of the variables that we are going to deal with, right? Then see, the very basic condition for an array, whenever we have to insert a new element, is that it should not be full. For example, like suppose if I have this array 1, 2, 4, 6, 7, right? So these are the elements of an array, and the size of array is how much? It is containing 1, 2, 3, 4, 5 elements. Means the index is 4, up to 4. So if size is equivalent to capacity, see, size is here how much? I can say 4 if the index starts from 0. And the capacity to hold these elements is also, means the 5 elements can be held in this array. So here actually it is size is equivalent to what? Capacity. So what if I want to insert a new element onto this array? So at that time, it should reflect that the array is already full, and we will be exiting, means it won't allow us to insert a new element into the array. So at that time, we should get an, not, I cannot say error, we should get a message that array is already full and leave. You are not allowed to insert a new element. So it is when the size of array is equal to the capacity of the array, means if the array is totally full, there is no vacant location in the array at which we are going to insert a new element, right? So for that purpose, we are going to do like this check. If size is equal to capacity, means if the array is full already, then it should print the array is full, right? Now what if there are some locations, means if this is the array, and I have some elements like 6, 7, 1, or I can say, okay, let it be, where I have 3 elements and there are 3 vacant locations, means blank location. So there is the possibility that I can add elements to this array. See, now I have to choose the location. At what location I want to add the element. See, if I want to add the element at the last, it is simply come up here. For example, if I have to insert at the beginning, insert at the middle, so at that time I have to use the condition accordingly. By adding the element at the end, it is easy. Simply move the last index to the next location, it will add the element. So what if I have to add at a particular location, either at the beginning of the array or at the last of, or at the middle of the array, right? So for that purpose, what I am going to check, I am simply shifting the elements from the position to end one index to the right. For example, if this is the index, like suppose it is the first index, it is the 0th index, starting index, and it is the second index. Like if I want to insert the element at the first index, second location, so what I have to do? I have to simply move the previous index, this one, to the second location. Means I have to increase it to 1 plus 1, right? So it will become 2. Similarly, the next one, 2 plus 1, it will become 3. So the new array would be like this. This is the 0th index, this is the first index, this is the second index, this is the third index, and so on. So here, initially it was 6. But I have moved this 7 to what? To the next place. So 7 will be moved here. And 1 is here and other 2 locations. So I have created a vacant location for an element which is to be inserted over here. So simply, there is only one step over here. Just write this, array of I plus 1 is equal to, it means simply whatever is placed at this array of I, it will be moved to array of I plus 1. Means whatever was over here at this location, it has been moved to this location. Simple. It was 6, 7 here, it got moved to here. So what about this place? It is now vacant. So then what I will do, I will simply insert, like suppose if I have to insert 8, I will simply write that insert the element 8 at this location. So this is how do we add a new element to an array. Hope it is clear. The algorithm part, basic.
రాత్రిలో ప్రతిసారి రోజుకొకరికి రోజు చెప్పాలి కదా మరి.
Yeah, am I audible? Is it clear? Any questions till now? Yeah, do confirm. Great. Okay, fine, good. Size -1. Yeah, it depends. See, it is algorithm. Whenever we write a program, at that time we have to precise the variables exactly. Let us write a program as well. Hope it is clear. Yeah, this is the program. Now let us write this program. I have written it somewhere. Let me check and we will simply copy it. Then we'll explain it there. Let me share the screen. Online Java compiler. Okay, this is the program. Hope screen is visible. See here, what we did. If you remember, the very basic thing is that we have to declare an array, and this is the way that how do we declare an array. Yesterday we checked it. It is an array having a capacity to hold 10 items, and all the items would be of type integer. Simple. Yesterday we discussed it. Int array is equivalent to new array, and then we are giving 3 elements to it. This is an array of, that is what we declared, right? It has got 10 locations, 1 2 3 4 5 6 7 8 9 and 10. So I have declared this array, right, having containing 10 locations. Then I am adding 3 elements to it, 5 10 and 20, like this. 5 10 and 20. So these are the 3 elements that I have added to it, right? So this is till this step. So this is how what I do. Then I want this 15 element to be inserted. This is the new element that I want to get inserted into this array. So I want 15 to get inserted into this array, right? And I have to specify a position. At what position I just want to insert this 15. So I'm assigning a position 2 at which I have to insert this 15 element. So this is the 0th index. It is 0 based index. This is the first index and this is the second index. So I just want this 15 to get added at second index, right? So what I have to do? Simply, if you remember previously, first I have to check whether this array is full or not. If this is full, I will say that array is full, the 15 element cannot be inserted. But that is not the case over here, right? The case is that I have already 7 empty locations, so I can add 7 new elements to this array. So in order to check whether this array is full or not, I have to simply check if size is equivalent to arr.length, then simply say array is full. We cannot insert a new element, right? But this condition does not fulfill over here, so I will simply go to the else condition, right? So I am checking if size is equivalent to arr.length. If this is true, then the loop will exit and it will simply print the message you cannot insert a new element because array is already full. But if we check over here, it is not the case. Now I will go to the else part. For else part, I have to check at what position I am going to insert the element. So here I have already specified that I have to insert the element at the second position. So for that, what I have to do? I have to move this element 10, not 10, 20 to this location. Means the new array which I am going to create would be like this. This is the first location, second location, third location, fourth location, and so on. These are other locations, right? So here I have 5, here I have 10. But what I am doing, check here. For I is equal to size minus 1, right? Size is what? 3. Already I have specified size. It is 3. Size minus 1 means I have to go like this from this to this. Size minus 1 is size is 3, it is 2. I greater or equal to position. Position is what? Position is also 2. Till I have to run this loop variable till 3. But if it goes to 2, then position minus means I have to decrease the position. Then at that time, whatever would be present at ARR of I, that will go to ARR of I plus 1. Means whenever it will check if size is equivalent to initially size minus 1. So it would be initially like suppose 3. Is 3 greater or equal to position? Yes, position is 2. So it will go here. Similarly, it will check for 2. Is this position? Again, I am checking it. See here, I will show you how for loop is actually working. So it will simply check size. Size is 3. Is size greater or equal to what? Position 2. Yes, it is 2. So it will position minus. Position will be, position was initially what? 2, it is 2. Then size will be now 2. Is 2 greater or equal to 2? Yes, it is again greater or equal to 2. To position minus, so it will go to 1. Now it is 1. Is 1 greater or equal to 2? No. So what it will do? The loop will exit and it will do ARR of I plus 1. Means ARR of 2 will be moved to ARR of 3. The value at ARR of 2 will be moved to the value of ARR of 3. Simple. Means whatever was present at this location, it will move to here. So here it was, I guess, 20. So 20 will be here. And then what I will do? I will insert new element at the ARR of position, whatever I have created. Means here, whatever was the element, it was 15. So 15 will be inserted over here. This is simple how this array is actually working. Insertion operation is actually working. Hope it is clear. Yes or no? Then simply I have to print the updated array. Is it clear? Yes or no? See, it is simple. Okay, fine. See, this algorithm holds for all other languages. Be it C, be it C++, be it this Java or any other language. You have to keep in mind what we actually are doing. Whenever you are inserting a new element into an array, it means you have to create a blank memory location, or I can say blank space, blank index. So how do you create a blank index? It is like, for example, you are 10 students sitting in a row, right? 1, 2, 3, 4, and so on. And there are, like, suppose 15 benches in the front row. There are 10 students already sitting, and I just want another student to get added to your in between you. So what I will do, the location at which I have to add a new student, I have to free that location, free the admin. For that, what I will do, I will tell you the fifth bench, like suppose all the students who are sitting at 6, 7, 8, 9, shift to one places to the right. So what you will do, you will shift to one places to the right, and the fifth bench will be vacant. Then I will bring new student, ask him to sit at this place. That is simple insertion. So here also what we are doing, we are simply creating a memory location, and in that memory location I am just inserting a new element, right? Okay. Yes, if I run this program, what we will see? Yes, after insertion you can check that I shown already in a notation. This was the array that I have created, that I have declared. So here it was 5, then it was 10. Initially it was 20, but that 23rd or second location I have freed. For what purpose? For inserting this 15. So here I have inserted a 15 element. So this is how do we insert a new element into an array, and this is the program. Only two things are to be checked. Initially, if the array is full. If it is full, it means we can't insert a new element. If not, just create a location. For that, what I have to do, simply run a loop to that location at which you are going to insert a new element. Just increment the index. That's it. Let me share the screen back. Okay, so now the presentation screen is visible. Okay, I hope this screen is visible. Yes, please confirm. Okay, now these are the key points. See, first of all, that I already discussed, that I already told you several times, that we have to check the capacity. If there is a space in the array, only then we can insert a new element. If not, we have to show that array is already full, you can't insert a new element. Then the second step is we have to shift elements, means we have to move all the elements from the insertion point to the end one position right. That I already told you. If you are sitting on the first row, if you want to accommodate a new student somewhere else, you have to move right, means you have to move to the end of the array. So that simply means shifting the element. Then insertion means place a new element in the vacated position, then update the array. This is simple. So these are the basic key points that we have to perform while inserting a new element into an array. Right? Now, see, this is important now. Time complexity. Can anyone? Okay, it is right written over here. There is no fun of asking this question. See, the best case complexity is order of n. And you know when it is best? Simple. When the element we have to insert is at the end. Why? Because you don't have to create location, shift elements, etc., etc. Simply get the element, put it at the end. That's it. So it is best case. Bring the element, check the capacity. If free location is there, bring the element and put it. No need to shift the elements. No need to go for this checking, etc., etc. Location checking and so on. So that is why the best case is order of 1. And you might be knowing it now well. What is this big O? Why are we writing like this big O of 1? So it is simply in the very go you can insert a new element. Now the worst case is what? It is order of n when the insertion is at the beginning, requires all shifting elements, means you have to move all the elements to right. So all the n elements you have to shift to right. For example, if you have to insert at the very first location, what do you have to do? You have to free this location. So for that, you have to move all these elements one place right. Right? So for that, it will require the complexity of order of n. Means whatever would be the element that you are moving, that would be the complexity of this, but of this insertion. So remember, these questions are asked, and it will ask you why this is 1 and why this is n. It's not like you have to only remember it. You will cramp the complexity of this is order of 1, order of 1. But you have to explain it. Why so and why so. So it is easy. Means when you have to insert at the end, no replace, no shifts. But whenever you are inserting at the beginning, so it means you have to shift all the elements. So that's why it is order of 1 and order of n. Hope it is clear. Just a quick thumbs up if it is fine. If you are not getting it, do let me know. If there is any question in between, ask me. See, the things are very important. Once you will clear these things, and I am keeping the things very simple. Okay, good. Good to see your responses. Okay. Now let us proceed further. Now the second operation in an array is the deletion algorithm. See, what was the condition for insertion that we were checking? What could be the condition for deletion? Just write your answers. Can we write for loop for int I is equal to 0, I less than or equal to, yeah, it is same. I equal to 0, I less than or equal to position. I equal to 0, I less than or equal to position. Yeah, you can write. Good. If array is empty, then no deletion. Great. It is simply, I am like suppose there is no student staying in the class and I am just trying to remove a student from the class. So that is equally likely absurd. So I have to check if there is no student in the class, so there is no provision for the deletion, right? There is no provision for removing the student. Similarly, if array is empty, so there is no provision for deleting an element. Okay, so it is simply deletion means remove an element from an array at a specified location, right? And if you remove the element, then shift the elements to the front, means fill the gap that has been created by deleting the element, shift the elements one place left, or if you remove two elements, then two accordingly, right? This is the algorithm. Simple. I have created the same algorithm like I have used for insertion, only a minor difference in the operation only. There also I have used start, here also we have start. There also I am declaring an array variables, etc., etc. Here also I am doing the same. But there I was checking for what? I was checking for the full array. Here I am checking for the empty array, means if size is equal to 0. There I was checking if there is, if all the locations in the array are completely filled, there is no vacant space, then I was just saying array is full, I can't insert. Here I am just checking if there is no element in the array, means if the array is empty, then at that time I am just saying that the size is equal to 0 and you can't delete an element from the array. So array is empty. But if there are elements in the array, I just want to delete that element, right? So for that purpose, what I have to do? Simply I have to check which element I just want to delete, right? If I have this element 10, 15, 20, 40, etc., etc. So these are the elements in an array. Right? And I just want to remove any of the element at a specified location. Right? So what if I will do? If position is valid, means position is greater or equal to 0, less than or equal to size, whatever is the size. If size is equal to, like, suppose 3, and here it is 0 index and third index, then I have to check the position at which I am going to delete the element. It should be between this, and it should not be like if there are empty location, no elements, and I am just checking that I am going for this. See, two conditions. First condition is that the array should not be empty. Now there are empty locations, and still I just want to remove the element at this location, although there is no element. So for that purpose, I am checking this condition. This position should be greater than 0, and it should be less than the size. Whatever is the size, means at the last location. If it is like suppose 3, so it will go from this to this. Only then it will delete the element, right? If not, print invalid. If I am going for this position, like suppose at the position 6, so there is no element, so it will simply print the invalid position, right? Now what if the position is now right, for example this position? So for that, what I have to do? Simply I have to remove this element. So in an array it is easy. What I have to simply change the index of this place to this place. Means if the index of this is 3 and index of this is 2, what I will do? I will simply change the index. I will call this 40, which was at index 3, to go to the index 2, and 20 will be removed. That's it. Simple. Whatever element was present at I plus 1, I will move that to I. Simple. There is no need to perform any kind of a rocket science calculation. It is easy. So getting it or not? Simple it is. What is the operation? The location at which you want to delete the element. For example, if it is like first location, 0th index, what I will do? I will free the element at the 0 index. How do I free the element at the 0 index? I will simply place this element at its index. Simply whatever was present at 1st location, I will call this element to get moved to the 0th location. So at 0th it was there, now it would be 15, means it will simply place at this 15, 20 and 40. So that is it. So I will decrement it by 1. So this is what? This is how do we perform the deletion operation. And the last step, set last element to 0 or null for cleanup. It is not that much necessary. So this is how do we perform the deletion. Hope it is clear. Yes or no? Now we will write the program for it. So this is the program. See, again I am going to discuss it. See, same way. Initialize and create an array. Initialize the size. This is the current number of elements in an array. For example, there are, I have placed 5, 1, 2, 3, 4, 5, right? Then int position means I just want to delete the element at the second position. Fine. So I have specified the position, means at the second position, whatever is the element, I have to remove that. So for that, these are the operations. This is the algorithm. First, I have to check whether the array is empty or not. So for that, I have to check size is equal to 0. If size is equal to 0, simply array is empty, nothing to delete. Then secondly, I have to check the position. If the position is there, right? But if that position is what? It is greater than size, means it is somewhere where there is no element. So for that also I have to check it is invalid position. So for that I am just checking position is 0 but greater or equal to size. This also I have to check. So this is I am checking. Then the operation is simple. Shift the elements to the left from position +1. Whatever would be the element, shift them to one place left to the location on at which I have to delete the element. So this is the procedure. Simply for int I is equal to position, whatever is the position, I is less than size, I size -1, I plus, then whatever is present at array of I +1, it will go to array of I. Means all the elements after this location will be shifted to one place left. So that is simple operation. That is simple deletion. Right? Let me write this program. Let me copy it. Deletion program. If you have any questions, please ask. Okay, this is the deletion operation that I have pasted. See here, this is the output. Oh, what happened? Okay, sorry, it got. Yes, see here. Is it visible? Just a quick confirmation. Please. Okay, see, this is the array that I have created, containing 5 elements. 1, 2, 3, 4, and 5, right? So I am just initializing and creating an array. So the size is like, what is the size? 5. Then the position at which I have to delete the location. This I have to delete the element. So it is the second position. Means 15 I just want to remove from the array. So delete operation. First check for the empty array. Simply if size is equivalent to 0, but array is empty. Fine. If position is less than 0, position is greater than equal to size, then invalid position. Fine. If these two conditions are not true, then simply I will go to this else part. So here I am just checking what? For int I, position, I is equal to position, I less than or equal to size -1, I plus. So the main operation that we always remember it. It is only shifting of the indices. That is actually doing insertion and deletion. Here I am just shifting this ARR of 1 to ARR of, like so ARR of I plus 1 to ARR of I, means the next to the previous one. One place left it is actually we are doing. So this is the operation. If we check here, this is the new array at which the 15th element was deleted. Let us check for this as well. Let me go with the size. See, if I will write size is equivalent to 0, let me check what will happen. So what does this mean? See here, array is empty, nothing to delete. What does this mean? Simply, I have like these elements, but the size of the this array, it is current number of elements, what it is holding. I have although I have initialized the array, but the number of elements that I am giving is 0. Similarly, let me again change it. If I am setting the position, like suppose position is, I can write 6. Let us check what will happen. Can anyone guess what could be the result? I am just typing position is equal to 6. What could be the output? Yes, invalid position. Great. Okay. Yeah, that I checked. Okay, so hope it is clear. The deletion operation is clear. Is it fine? Just a quick confirmation. Is it clear? Okay. Yes. Now these are see, these key points and complexity is important. Once you are understanding the concept of insertion, deletion, or any other operations, the key points are important, because these key points and the complexity, that is what you will be asked, whether in your interview, whether in your exams or any other places, right? Most of the times you won't be asked to write a program, but whenever you are writing an intro at that time, but most importantly, they will come to know your understanding these key points about any operation, because this is important. Once you have clear understanding of the algorithm of the program, and language nowadays, these programming languages, they are like evolving. After every 5-10 years, new programming language is coming. You might be knowing it, but the concept, the algorithm, that will always remain the same. And that is the main thing which is actually building your mindset, which is actually building your confidentiality, which is actually building your problem solving capability. Once you have a thorough understanding of the concept. See, if we see here also, these are the key points, and you will be asked it several times. What are the main key points that you are keeping in mind while performing insertion in an array, deletion in an array, or any other operation, search, binary search, etc., etc. So remember these. Like there, I was just taking what for the full array. Here I am just checking the empty array. Only then I can delete. Then position, I have to check for the position, whether the position is there or not. If the array is already like there are some elements in the array, but you are setting a position at which there is no element. So at that time again, I must ask that we can't delete an element at this location because there is no element. It is an invalid position. Then simply moving all the elements of the deletion 1 point left. That is the main operation. Means add whatever is present at I plus 1, move them to I location. So this is the core operation, both in insertion as well as but in insertion it is reverse. Whatever is present at this I location, I will move that to I plus 1. Means I am just creating a location and moving the elements to right. And here in deletion, I am just creating a location and moving the elements to what? Left. Then I will update the size and clean up the array. So these are the key points. Fine. Now, after that, there comes the complexity. See, this is again important, because during from day one, I am more concentrating on these things, because these are the things that are being asked from every program, from every algorithm. And you don't have to remember the things now. Just a concept in your mind, you should be able to reflect the complexity. See, what is the best case? And when is the best case? Best case is B big O of 1. And when it is when we are deleting the element from the end. Means when the array is like this, you don't have to check for any kind of a thing. Simply what? Put the last element and delete it. Simply move the last index to the one place left. And when is the worst case? When we are deleting from the beginning, means it will require shifting all the elements to the left. Similar in case of insertion. Whenever you are inserting at the front, shifting all the elements to what? To right. Here also, whenever you are deleting an element from front, shifting all elements to left. So this is the worst case. So you have to remember, in while inserting an element into an array, best case is whenever we are inserting at the end, and whenever we are inserting at the beginning, the worst case order of end. Same is the case with deletion. Any questions till now? Yes. Any questions? Okay, I hope it is clear. Just a thumbs up. If the things insertion and deletion is clear, we can go forward. Okay, so this is the walkthrough that we did. I guess I explained this with the help of an example, same example. Here the size was 5, value 15, which I am going to delete at the second location. So I will be shifting this 20 and 25 one place to left. So the new array would be like this, and its updated size would be 4. So the last element set will be equivalent to 0, means null. So this is simply that we did. Okay, shall we proceed? Great. Okay, let us proceed to the second part. See, this was insertion and delete operation. And the third operation, I guess we discussed it yesterday as well. It is the search operation. And search means simply finding whether the element is present in an array or not. Yesterday I also gave a brief overview of these search algorithms, binary search and linear search. Today we will discuss it in detail. Yes. Okay. Today we will discuss it in detail. See here, search is simply finding an element in an array. Means we have to check whether the element is present in an array or not. Fine. So again, I have devised the same algorithm in that manner only, so that things will become more clear. See here, start like in those algorithms, declare the array. See, you can follow the steps like this. If you follow like this, you don't get confused in between. And when you follow a common strategy for all the algorithms, the things will be easier and clear. Only you have to change one or two things. Like in insertion, you have to look for the full array. And in deletion, you have to look for the empty array. And in insertion, you have to update what? You have to update I plus 1 is equal to I. But in deletion, you have to update what? I is equal to I plus 1. Only these two things are varying. Rest of the algorithm will remain same and the program will remain same. So here also what we are doing, starting, then declaring the array. Then again here I am just checking what? If the array is empty. If the array is empty, it means there is nothing present in the array. You can't search anything. Fine. It is like yesterday I also gave the example. If like suppose in this meeting we are like 200 participants. I am just searching for ABC. Okay? If there is ABC, it will be found. If not, ABC will not be found. But if there is no one in the meeting, I still again try to find ABC. So it is like asking an awkward question. There is no one to whom I am asking. Fine. So it is like, if no one is in the class, so I have to check that condition as well, because algorithm does not know. We have to ask the algorithm to perform the operation. Humans will they will feel that the room is empty, there is no one. Why do I shout? Is the student ABC present in the class? That is using our intelligence. But algorithm does not know like this. We have to ask the algorithm. You have to check. So first condition is he will check if the array is empty. So he will stop over there. Fine. So for that, what I am doing, I am just checking if the array is empty. Means if size is equivalent to 0. At that time, what I will do? I will say the array is empty. Now, what if element is there? So actually, see, search, we can perform search in multiple ways. Here the search that I am using is linear search. Binary search is also there. That is actually using divide and conquer strategy. So I will be first explaining you different algorithm strategies. Only then I will explain about binary search, right? So that would be much then it would be much more clear. So here I am just using linear search. Linear means I am searching sequentially, linearly. It is also called as sequential search as well. So here I am just simple. See, the operation is very simple. I am just searching from 0 to the size minus 1. If there are n elements, so it would be n minus 1. Yeah, size minus 1, depending upon the variable whatever you are using. So simple. I guess yesterday I also discussed it. For example, if I have to check whether the element 5 is present in the array or not, so what I will do? So I have to check for all the indices. If ARR of 1 is equal to 5, if not, then go to second place. ARR of 2 is equal to 5. If not, then go to this place, this, and so on. Right? So if it is found somewhere, I will simply return the location of that index, and I will say element 5 found, and that is it. Simple. It is equally likely, like suppose there are 20 students in the class, right? They are sitting in 20 benches, one after the other. I have to search for student XYZ. What I will do? I will go to student 1. What is your name? ABC. Second, what is your name? He will say PQR, etc., etc. Till I will search one by one. 1, 2, 3, 4, till I will reach to what? XYZ. If XYZ is there, I will say element found, and this is the location. If not, I have to search for all the locations, and at the end, I will say element not found. Fine. So this is actually the search algorithm. We discussed it yesterday as well. Today I gave an algorithm like this. Okay, so this is the I can say program for it. Let us check. I guess we discussed it yesterday as well. Let us do it again. Okay, let me overwrite this program with this one. Let us. What happened to this? And these are not being copied. What happened to it? Okay, see here. Hope it is visible. Yes, is it visible? Yes or no? Please confirm. Linear search. I guess we did it yesterday as well. See here. Simply what I checked. Although it is a different program. I was supposed to write that program. Okay, let it be. Here what we are checking? We are simply checking for the length. Then we are returning it. Here yes, once the element is found, we are just checking. See here in target 7. If it is there, so I will say element is found. So here if we check, I am just looking for the index, first index. So here the element found at index is 2. Fine, at index 1. Here I am checking. So this is actually, here the program was much better which I have used. See here, it was simple. If size is equivalent to 0, array is empty. It is simply the algorithm that I have written. Linear search through array. I am just searching over here for the till size. Target element found. If not, I'm exiting the loop. Then display the result. So this is actually linear search that we are doing. Now the key points about the linear search. These are the key points. See here. First, verify if the array has elements to search. We have to check if there are elements that we are going to search. If they are there, only then we can search. If not, we can say simply this array is empty. So we have to search whether the elements in the array are there or not. That is the second thing. If that element which we are going to search is present or not, that is a different story. But the very basic thing is array should not be empty. Right? If our element to be searched is not there, that is a different story. Still it will perform the operation. But the thing is, array should not be empty. Keep it in mind. So that is why we are going for the empty check. Then linear search, or I can say sequential search, will simply sequentially check each element until match is found. If match is found, it will return the element. If not, it will simply say the search is unsuccessful. Means it has performed the search, but the element is not found. So we have got two types of searches actually. It is called as, hope the screen is visible, this presentation screen. Is presentation screen visible? Yeah, just give me a confirmation about the presentation screen. So what are you viewing? Okay, yes. Okay, great. So here these are the key points. See, the very first condition is empty check. Means we have to check whether the array is empty or not. If it is empty, then we are simply saying that element cannot be found because the list is, because the array is empty. Then we are sequentially searching for the element. If the match is found, we will say the element is found and search is successful. If match is not there, still we are just saying the search is unsuccessful. So again, I am repeating that we have got two searches. One is successful search and another one is unsuccessful search. And we are being asked sometimes the question, what is the time complexity of successful search? What is the time complexity of unsuccessful search? Unsuccessful, like suppose linear search. So you have to keep in mind what is successful search and what is unsuccessful search. Successful search is simply when you are searching an array and you are finding the element, whether at first location, last location, or in between. But unsuccessful search is simply you are searching an array and you are searching all the elements till end, but the element which you are trying to find is not found there. So at that time, it is always the worst case, this unsuccessful search. It is always worst case complexity. This successful search can be worst or it can be best. If it is found in the very first location, we say it is best case, order of 1. If it is found at the last location, we say it is worst case. But remember, this unsuccessful search is always the worst case. because here whether in binary search, whether in linear search, or whether in any other method, so here whatever you are doing, you are completely searching each and every element in the list, and at the end you are not finding that element, right? So this is actually we are doing here. So then result handling is simple. It will return the index if not found. It will return the return -1 if not found. So this is unsuccessful search, right? So here is the approach. Easy to understand and implement because we have checked it. It is easy and very basic. Now the most important part, complexity. Yesterday we discussed it as well. What is the best case complexity? Order of 1 when the element is at the first position. Means I am just searching for someone in your class and that is the roll number 1. I am just asking the name, who is ABC at the very first location. What is your name? ABC. So my search is finished. Whatever I was in need of, I found it in the very first location. So luckily it is best case. Fine. So this is the best case. Whatever you are finding it in the very first go. So that is the best case and it is order of the 1. And average case is simply when the element is in between, in the middle. So at that time it is simply number of elements divided by 2. But worst case is when you have to search the entire array and you are finding the element or you are either not finding the element. So that is the worst case. So at that time it means your element is present in the last or it is not present at all. Hope this is clear. And I hope you are just understanding the complexity. Yes or no? Just type in the chat box. If you are getting it, just type in the chat box. If you have any questions related to it, see, it is not that much difficult as we are thinking. It is very easy. The only thing is you have to understand the things in your mind first. Once you will get to know these things, it becomes very much easy. Okay, good. So these actually are the operations. Although we have not, we have done, I guess, create we did, read also we did. Update is simply what? What is update? Whatever operation you are performing, then update it. You are first inserting, deleting, then inserting with a new, or you are replacing the element. So that is same. Simply from the previous example that we did, research that we did in every example, update similar to insert or delete, and delete that we did in the previous example. So these are some of the operations that we have discussed. Hope it is clear. If you have any questions, ask me. What is the time? The time is 20:10. So we'll go for a 10-minute break. Then we will see the basic algorithm strategies. That is much more important because once you have a clear understanding of the algorithm strategies, then you can apply those strategies to different kind of problems. So that is again important. Okay, pop, it is in stack whenever you are deleting the element. Okay, let us go for a break. Is it fine? So we will be back at what time we'll be back? It is 20:10. So we'll be back at 20:20 is fine. Okay. So at 20:20 we'll be back. Then we'll discuss algorithm strategy. Okay, till then, take care, have a cup of tea, just relax. Thank you. Okay, welcome back. Good evening. Yeah, am I audible? Okay, let us continue. Great. Is my screen visible? Just a confirmation. Okay, don't put unnecessary messages to your colleagues. I don't want to name anyone because I am checking your messages. It's the last warning to all of you. Don't put unnecessary messages to your colleagues. Okay, fine. Now we have seen the search techniques, or I can say different search techniques for different data structures. Here we have seen like the search technique for arrays, right? And you know, search is a fundamental operation in computer science, isn't it? By which we can find different elements, or I can say a particular element in data structure. So we have got two main search techniques. One is linear search and another one is binary search. And linear search we discussed, isn't it? And the complexity of linear search, worst case complexity is order of n. And it is best complexity is order of 1. And we have checked when is worst and when it is best. And the element is found this at first location or at the last location, that we discussed, I guess, in detail. Now the question is, when is this binary search optimal? When we can go for the binary search? Right here, it is best for unsorted arrays. And you might be knowing it well. Yesterday I gave a brief idea about the binary search and the precondition for binary search. So here we can say, when is this search technique optimal for which kind of arrays? So it is optimal for unsorted arrays, or I can say smaller data sets. Means whenever the size is very, very small. Fine. So this is, remember it, when the arrays are unsorted. See, the binary search, although its complexity is order of log n, but the condition is the array has to be sorted. So what if the array is unsorted? Man lo, we have got an unsorted array and you want to search an element. What you will do? For unsorted search, I am just saying that linear search is important. But if I will do binary search for this unsorted array, so what I have to do? I have to first sort that array, isn't it? And you might be knowing it well. What is the complexity for sorting? It is order of, can anyone? Complexity for any sorting, best sorting technique. Any best sorting technique, complexity. Yes. Complexity of any best sorting technique. I can say it is n log n. No, sorting is not big of 1. It is n log n for merge sort. For other sorts, it is always like order of n square. But for merge sort, it is n log n. So it means first of all, I have to sort this array, unsorted array. Now I can apply what? Oh, sorry, it is order of and log n. Only then after sorting I can apply what? I can apply binary search. So it means for binary search, what is the complexity? Log n. So it means in order to apply binary search on an unsorted array, first the complexity is n log n, then it is log n. So that is why I am just saying that for an unsorted array, we will be going forward. We will be going for linear search. Right? So for binary search, the array has to be sorted. So this is the complexity for binary search. We have discussed it yesterday also, and we'll be discussing it in detail while discussing the algorithm and while writing the program for this binary search. And it is requirement is, always remember it, the requirement for binary search is the array has to be sorted. Keep it in mind. The array has to be sorted. Our array should be a sorted array, only then we can apply binary search. And it is best for large sorted data sets. This one, linear search, is best for smaller data sets. This is best for large data sets, but the data sets has to be sorted. Right? So this is the comparison between linear search and binary search. And before going deep into the detail of binary search, we will be discussing the algorithm strategy, because this binary search, if you remember yesterday, I also told you that the binary search follows which strategy, which algorithm strategy? Can anyone? Which strategy it is following? Binary search. Which strategy it is following? Yes, D and C, divide and conquer, right? Great. So it is following actually D and C, divide and conquer, right? So I will be discussing these design strategies today itself. So before this going deep into the detail of binary search, let us go to the different algorithm design strategies. Okay. See, there are, I guess, there are so many algorithm design strategies, and we'll be explaining few of the algorithm strategies over here. The very basic and the fundamental design strategy, or I can say design paradigm, is divide and conquer. So it is the most basic or most not frequently used, most used algorithm design strategy or algorithm design paradigm. Right? So here what we'll be doing, see, in this we are given a problem in design. This, it is simply divide and conquer, or I can say divide and rule. Divide, then conquer. You have a big sub problem, right? You have a big problem. You will divide this big problem into the smaller sub problems. It is simply divide and then conquer. It was a big problem, divide it into two or more than two. Then again divide that sub problem into further sub problems. Then similarly till you will reach a smaller sub problem. Then solve that sub problem, solve this sub problem, combine the solution, solve this, combine the solution, combine all the solutions, and you will solve the big sub problem. So this is actually how this divide and conquer is working. It is simply breaking down a bigger problem into smaller sub problems, and then it is solving these sub problems recursively, and then combining their solutions in order to get a solution of this bigger problem. There are so many examples of this, I can say, divide and conquer. One is merge sort, we have quick sort, we have binary search, and we'll be discussing it today itself. We have Strassman's matrix multiplication, we have closest pair of points. So these are some of the examples that we are solving using this divide and conquer strategy. So we'll be, I guess, explaining all of those, but today for sure we'll be explaining the binary search. So before binary search, that is why I discussed the design strategies. And in algorithm, the design strategies are important. Whole algorithm design and analysis and design of algorithms. So that revolves around these design strategies. And in that, we are actually solving these problems one by one using their respective design strategy. So here in this case, we'll be explaining the binary search. Then another design strategy is greedy method. Can anyone tell me what is greedy method actually? Yes. What is greedy method? Till then, I will create an example of greedy method. You just type in the chat box what is greedy method. I will create a sub problem. It's not a problem by which I will explain the greedy method. Type your answers. Okay. Yes. Have you written your answers? Greedy method. Okay. Someone has written repo strategy where decisions are made based on the most immediate or locally optimal choice. May I know what is this locally optimal choice? Optimization problems, great. Optimal profit, crucial algorithm, feasible and optimal solution, best option at that time, great. Find shortest path, yeah. So all the answers are almost fine. Now let us explain. See, if you see the definition, it makes the locally optimal choice at each step to reach a global optimal solution. See, yesterday, I guess day before yesterday, I already told you, in an algorithmic problem, we are always trying to find the optimal solution, right? See, there are so many feasible solutions. Feasible solution is a solution to a problem, means which is feasible. That can be a solution. And the optimal solution is best among all the feasible solutions. So this greedy is simply what is best at that time. What is best at that instant, right? Like locally optimal choice. Let us take an example. Let us say I have to go from station A to station B. This is the best example that I can explain in order to make you understand the greedy method. See, it is simple. And these are the weights 5, 3, 15, 1, 10, 15, 7, 2, 1. So I am at station 1. Yeah, station A. I have to go to station B. Keep this simple way to explain you this greedy strategy. See here, as I already told, the greedy method is checking what is best at that instant. It is not looking for the future. It is not taking care what will happen in the future. It is only greedy. Greedy is simply what? Greed. Without looking forward, what could be the repercussions or something like that. It is greedy at that, like we are greedy at some time. जैसे हम बोलते हैं कि लालच बुरी बला है. So here also happens most of the times with this greedy method. लालच बुरी बला है. So we are greedy. We are what? Trying to find the best at that instant only. We are not looking for future. We are not looking what could happen in the future. Like here, I have the costs 5, 1 and 7. So as per greedy method, which is optimal, which is the best among these three? Which is the best among these three? Which path should I follow among these three? Yeah, please answer it. So simply I will have to follow the path having cost 1. Like suppose, let me call it C, station D, station E, F and G. These are the stations. So I have to go from what? I will first go from, as per greedy, it is A to B, A to D, having a cost of 1, right? Then after that, there is only one process, is D to F. The cost is 10. Then it is F to B, the cost is 15. So what is the total cost? It is 26. So the mean cost that I got from using this greedy method, while following the greedy method, it is 26. So what could be the, what are other possibilities for the solution to this problem? What are the other feasible solutions? It can be like, if I go like this way, A to C to F to B, and what is the cost? 5, 3, 15, 15 and 15 is 30, right? And what is the other way? It is A to E to G to B. And what is the cost? It is 7 to 9 plus 1 is 10. So which one is optimal? Which one is best? Which is the shortest path from A to B? Yes, which is the shortest path from A to B? It is from A to E to G to B, and the cost is only 10. But what is the path as per the greedy method? As per greedy, it is like what? It is, yes, what it is? It is A to D to F to B, and the cost is 26. So as per greedy, we are not getting the optimal solution, best solution. See, it is not always possible. Greedy is sometimes giving the optimal solution, but here in this case, I'm just explaining you the greedy approach. Right? So here we are getting the cost of 26, but it is not optimal. Optimal is what? Optimal is 10. The best is 10, and the path is A to E to G. So greedy is simply checking the locally optimal choice. What is local? Means at that instant only. It is not looking for the future. That is what is happening after that station. Then after that, there comes the problem of this dynamic programming that we'll see, I guess, in coming lecture. So here I am just saying that greedy method does not give always the optimal solution that we have seen in this example. So this greedy is simply making what? Locally optimal choices at each step. See here it is making this choice. If there are multiple paths from here, so there also it will make a local choice, whatever would be the minimum. Similarly, after that station, it will look for the local minimum. So at every step, at that instant only, so it is looking what? It is looking the local optimal. What is locally optimal? Although that can lead to more cost in future path, in future stations, but it is looking for the local optimal. And there are so many examples which can be used, which can be solved using the greedy method. Like you can check, you have got Kruskal's algorithm and Prim's algorithm, and you might be knowing it well. What are they actually? They are used to find the minimum spanning tree. Can anyone define what is a spanning tree? Quickly, within 2 3 10 15 seconds. See, I am actually covering all the concepts now in order to give a overview of DSA. Yes, what is a spanning tree? I know. Anybody? Shortest path where we can reach from the start. Where see, actually spanning tree, it is a subgraph of a graph, right? And we just want to, I can say like this now, to create a subgraph of connected, and this all the edges, all the vertices must be connected, right? And the derived graph which I am creating from the original graph, that must be undirected, and it should include all the vertices of the graph. Actually, it is not the topic right now, but still I just want you to like, suppose for example, I am like clearing my drawing. If I had this graph and I have to create a spanning tree of this graph, it is ABCD, like suppose. So if I have to draw a spanning tree for this graph, what I have to do? The spanning tree is simply a subgraph of this graph, and this graph should be what? It should include all the vertices. Means if it has got 4 vertices, the subgraph must contain all the vertices, and it should be undirected. And the second condition is that it should not contain loops. So this is the subgraph of this graph, and I will say this is a spanning tree. So spanning tree is simply what? A subgraph of a graph, undirected, and it is not containing any kind of loops, or I can say cycles. And we have got 2 algorithms for this spanning tree. One for finding the minimum spanning tree, means if there are now weights on each edge of this graph, then I have to find a subgraph which is having minimal cost, minimal spanning tree. And for that, I have got 2 algorithms. One is Kruskal algorithm and another one is Prim algorithm. And the only difference between these two is one algorithm is actually it is assuming that whenever you are adding a new edge, that should be connected with the what? That should be connected. This is also a spanning tree of this graph. This is also a spanning tree of this graph. This is also spanning tree. So there are so many. I guess there is one formula. We call that as Calais formula. That is used to find the number of spanning trees in a complete subgraph, complete graph. I hope you might be knowing that. We call that as Calais formula. That is asked most of the times in some exams. What should be the number of possible minimum spanning trees of this graph? If that is a complete graph, you have to apply that Calais formula. I guess that is 2 raised power 2n minus 1. I don't remember that exactly. I guess yes, 2 raised power 2n minus 1. So for that, I have got 2 algorithms. One is Kruskal and Prim. And these algorithms differ only in one is supposing that if you are adding a new edge to the spanning tree, it should be connected with the previous edge. And one is supposing there should not be any condition for the connectedness of these two. Okay. So this is how do we find the spanning tree and everything else. So this also is making use of what? It is also making use of this MST, minimum spanning tree. Then after that, another algorithm is Dijkstra's algorithm. That is also a shortest path algorithm. Then Huffman coding, etc. And then we have knapsack problem. Fractional knapsack is the means we have a kind of a bag and we have to place weights, profits, etc. That is another problem. So we are solving these problems with the help of this greedy method. Right? Hope it is clear. Yes, please tell me. Just a confirmation. Just a confirmation. Okay. Yes. So another strategy after divide and conquer, greedy, and we have got dynamic programming, right? So dynamic program is also it is also solving problems by breaking them into overlapping sub problems. Like you can have a Fibonacci series, or you can have this 0-1 knapsack. There is difference between fractional knapsack and 0-1 knapsack. Fractional is simply whenever we are having that bag, it is supposing to include this na fraction of the object of that which we are going to put into the bag. But in 0-1 knapsack, either you can put the object in the bag or you cannot. That is why 0 and 1. I guess I will be explaining it in further if we will get the time. So this actually this dynamic programming is simply solving the problem by breaking them into overlapping sub-problems and storing their result. See, here it is memorization or tabulation. I will explain it in detail, but here for the time being, you will simply remember. But it will solve the problems into overlapping sub-problems and sorting their solutions. Fine. Now there are so many examples which we can solve using this dynamic programming. It is like we have Fibonacci series, we have 0-1 knapsack, matrix chain multiplication, LCS. You have got this Floyd-Warshall algorithm, or even like this TSP, traveling salesperson problem. So we have got so many problems which we can follow using dynamic programming, and I will explain some of the problems in coming lectures, right? Then comes backtracking. Backtracking is also an important design strategy, right? And backtracking is simple. See, it is simply whenever you are trying to find a solution and you are reaching to any kind of a dead end, what will you do? You will simply backtrack your path. So that is backtracking. It is systematically searches for a solution by exploring possible candidates and abandoning paths that fail. For example, like suppose I am telling you there are 2 tunnels, right? And there is gold, right? Or more than 2 tunnels. It's not mandatory. Just an example. Right? It is a dead end. We don't know whether the tunnel is closed or tunnel is opened. Right? So I will start search for this gold. Whenever I am following the path, I am going, and but at the end I am searching that the tunnel is closed. What will I do? I will simply backtrack. I will backtrack my path. So whenever it is closed, it means the solution is not there. When we are finding that the solution is not there, so at that time what we'll do? We will backtrack. We will simply backtrack our path and start finding in the next tunnel. And whenever we will go, and we'll find the solution, we'll find the gold. So this is simple backtracking method. So whenever you are going to find a solution, if the solution is there, well and good. If the solution is not there, what will we do? We'll backtrack the approach and follow another way. Like you might be knowing about the n queen problem. If you have an n by n chessboard and we are placing queens on that chessboard, it can be a 4 by 4 chessboard or 2 by 2 chessboard or like 8 by 8. The order of the size of the chessboard should be 2 power n by 2 power n. So like suppose if it is 4 by 4 chessboard and you have to place queens on this chessboard, like suppose the first queen I am placing over here, and you might be knowing, I'm just telling it quickly. I hope you might be knowing the concept. So the condition for this placement of these queen is that no 2 queens can be placed on the same row, neither on the same column nor on the same diagonal. Right. So for that purpose, if I am placing the queen 1 over here, now the second coin I cannot place over here, I cannot place over here, so here I can place. Right. Now the third row, here I cannot place, here also I cannot place, here also I cannot place, here also I cannot place. So it means that the third row will remain empty. But the condition is I have to place 4 queens along the 4 rows. So it means I have to backtrack the solution. So whatever I have written, I will backtrack. So I will go here in this row, I will remove this queen and I will place it over here. Then I will find the solution. Here also I cannot place, here there is a possibility. Let us check. Then here also I cannot place, here also I cannot place, here also I cannot place. So here also I cannot place. So again I have to backtrack. So here again no way, here again no way. So what I will do, I will shift the first queen to the second column, right? So here I can place me. This is backtracking, means whatever the way I was following in order to find the solution. If I am finding that this is not the way to find the solution, simply backtrack. Whatever you are tracking, backtrack it. So here I was placing, place it now here. So here, this is the solution. So this is the solution for this 4x4 chessboard with the help of backtracking. Similarly, another problem is Hamiltonian cycle. You have graph coloring, you have subset problem, you have Sudoku solver. So these are all the problems that we are solving with the help of backtracking method. Hope it is clear. Yeah, there are so many problems by which which can be solved with the help of this backtracking method. Yeah, if you have any questions till now, please ask. See, these are important strategies. That is why I try to cover this beforehand. Is it clear? Just a quick thumbs up. Yeah, almost whatever time permits, I will try to cover all the things. But you have to bear because for that purpose, I have to go a bit fast. For the concepts, but which are important, those I will cover in detail. Like I have covered search, insertion, deletion. But the late other concepts, I will be going a bit fast. But the thing is, you have to grasp what I am saying and you have to revise the things. I will try to cover all the concepts in algorithm design because that is more important. And in data structures, I will be covering the most important data structure like arrays, linked list, queue, stack. Now, once you are familiar with all these concepts, you can relate the things. No, class is not done yet. There is one more strategy. We call that as, I guess it is branch and bound, I guess. Yes, it is branch and bound. So it is another design strategy. So here it is simply now whenever you are trying to find the solution by branching it down. And if you find that you are not finding a solution, then you bound that. So there are problems by which which can be solved using this branch and bound. We have got TSP, traveling salesperson. We have got 01 knapsack, integer linear programming. And remember one thing, the same problem can be solved using multiple design strategies. It is not hard and fast rule that a particular problem can be solved using only a particular design strategy. Like suppose if you have checked this 01 knapsack, it was solved by what? By dynamic programming as well. Right? So it is not hard and see here the difference would be in the performance analysis that we will be checking, or that you might be knowing very well. By which strategy you are getting a good performance, by which strategy you are getting a good performance analysis. So it hardly matters by which design strategy you are solving a problem. The main thing is the performance analysis should be there, and there should be a formal approach of that problem when we solve the particular problem using a particular design strategy. So this is these are some of the design strategies that we have discussed. If you have any questions, you can ask. Then we will go to, I guess, binary search is there. Yes. Here, this is the comparison of these design strategies. Your screen is paused, right? Okay, my screen is not visible. Yeah, now it is visible. See, this is the comparison between these design strategies. If you check, hope it is visible, the comparison screen. Just a confirmation. Great. See here, the very first design strategy that we discussed, it is divide and conquer. Here, what are we doing? It is simply we are dividing the problem into smaller sub-problem, then finding the solution of each sub-problem and combining them back in order to find the solution. It is efficient. The complexity for most of these divide and conquer, because if you remember, yesterday we discussed about that recurrence relation, ATN by B plus F of n, and almost all those problems which are solved using divide and conquer, they are having that recurrence relation, ATN by B plus F of n. Most of the problems, they will be having their recurrences of that form only, ATN by B plus F of n. Because if you remember, I have discussed at that time what is A, what is B, and what is n by B. A was the this number of sub problems, n by B was the size of each sub problem, etc., etc. Right? So we can be making a recurrence for each of the sub problem using divide and conquer. That is why, if you remember, there also the complexity was for merge sort, it was n log n. It but may have higher memory usage, and for that binary search it is only log n. So these are some of the pros and cons. Similarly, we have got greedy method. For greedy, if you check, it is optimal substructure and greedy choice property that I explained with the help of that example. It is fast, but not all. Remember here, not always optimal. And I have explained one case of this as well. It is fast, but it is not always optimal. And I have explained one, that shortest path algorithm. Although that was finding a solution, shortest path, but the shortest path was not optimal. So you have to remember it. Then similarly, dynamic programming, it is overlapping subproblems and optimal substructure. It is optimal but high space complexity, because it is making use of what? It is making use of recursion, and it is making use of memorization. It is actually doing. If you remember Fibonacci, for every Fibonacci call, it has to remember the values in this memory stack. We call that as a memory stack. So it has to remember the values. For that purpose, it is having high space complexity, this dynamic programming. Then we have got backtracking. It is it includes exhaustive search, because it is combinatorial problem. It guarantees solution but slow, because it is trying to find. If you check that chessboard, if you go with the 8x8 or 4x4 chessboard, it will find the solution if there exists. That is the thing. But the solution is always there. It will try to find the solution, but that can be slow in its exponential case. Simply then, last time we checked branch and bound optimization problem with some constraints. It reduces search space but complex, because it is bounding the solution. Whenever it is found that the solution is not there, it is bounding that, but it is complex. So these are some of the pros and cons of these design strategies. Hope it is clear. Yes or no? So binary search we didn't cover, we will cover it in the next session. If you have any questions, you can ask. Yes. Any questions till now? Hope it is clear. If it is clear, just a quick thumbs up. And try to revise these concepts, because I have given only an overview of these design strategies. Okay, all clear. Thank you. In these strategies, which method is best? See, each strategy is best as per its use case. Like greedy method, we have knapsack problem, right? That knapsack cannot be solved using divide and conquer. So as per the design strategy, we have a particular kind of a problem, right? So this is actually what we are doing. These pros and cons. On that basis, you have to find which strategy to apply. Is conducting any test on this, sir? I don't know about it. Each strategy is best as per its use case. Okay, so I guess we'll wind up the session over here. Thank you so much for joining the session. Good night. Take care. Bye-bye.
Yeah, okay, sir. Thank you. We'll meet again by tomorrow at 7 p.m.
Tomorrow or Monday?
Oh, okay. I'm sorry. Tomorrow is Saturday, right? Yeah. So Saturday and Sunday we don't have a session. Again, we are meeting on Monday only.
Okay, fine. Thank you.
Yeah, thank you, sir. Yes, students, as I informed, today, like tomorrow and day after tomorrow, Saturday and Sunday, we don't have a session. We are meeting again on Monday. Thank you all. Thank you for joining. Good night.
Good night. Bye-bye.